Hello everybody, this is the midterm exam review worksheet for grade 5 science at the International School of Innovation. Let's start with the parts of the simple electric circuit. As we know, electric circuit can be defined as a complete path where electricity flows from a source to the load and back to the source. We have four main parts of a simple electric circuit. Number one, it is the source. The source is where the electricity comes from or the electric current comes from. Mainly, it's the dry cell or the battery. Number two, we have the wires. Connection wires are the parts of the circuit where electricity can flow through them. This is the second part, the wires. Number three, it's the device. The device is what consumes electricity on its operation. When it's operating, this one consumes electricity, we call it a device. Example about the devices, we have light bulb, we have television, we have refrigerator, we have electric fan, we have microwave, we have computer, camera, whatever those that are operating on electricity, they are called devices. Number four, the switch. The switch is used to open or close the circuit. When it's open, so no current can flow through the circuit. When it's closed, current can flow through the circuit. So we have four main parts: the source, where electricity comes from. We have the wires, they are parts of the circuit where electricity flows. Number three, we have the device, is what consumes electricity on its operation. And number four, we have the switch. Conductors and insulators. What the meaning of conductors and what the meaning of insulators? Some materials, they are conductors. Why? Because they allow electricity to pass through them. These are called conductors. Example about this: metallic spoon is an example about conductor. Iron, example about conductor. Copper, example about conductor. Iron nail, an example about conductor. Gold is example about conductor. While insulators, they are objects that do not allow the electric current to pass through them. Examples about insulators, we have plastic, we have paper, for example, we have wood. These are example of insulators. A series circuit. When two bulbs can be lit at the same time in a closed series circuit. Now we can start with a series circuit. What is a series circuit? A circuit that has only one path for the current to flow. This is called a series circuit. We have only one path for the electric current to pass through. This is called a series circuit. The current flows in a path from the battery to the first bulb, to the second bulb, and back to the battery. This is called a series circuit. In this case of series circuit, if both bulbs are not damaged, they will glow normally, they will light normally. When one bulb burns out or it's unscrewed, the flow of charges will stop. So the whole circuit will fail. So whenever we have one bulb that's not working, it's not working, the second it won't work. This is the case of the series. So in the series circuit, we have two bulbs. One of them is not operating, the other will not operate too. Opening the circuit will cause the two bulbs to put off whenever we have an open switch. Moving to other type of the circuit, which is called the parallel circuit. The parallel circuit is different from the series circuit that it has more than one path for the electric current to flow through. In the parallel circuit, the current has more than one path to flow through. If all parts are working, the currents will flow normally and it provides electricity. Here, if one part of the circuit is open, what will happen? The current can flow through another path normally. Since here we have two ways for the electric current to pass through. This is the first, this is the second. We have two ways for the electric current. So the parallel circuit has more than one path for the electric current to flow, while in the case of the series, we have only one path. So if the charges are stopped from flowing along the one path, they can move across the another path. Electromagnetism. What is an electromagnet? A magnet that are made with electric current. With the help of electric current, they are called electromagnet. That's the name. Electromagnets. Magnets that are made with the help of electric current. What do we need here? We need a nail, we need a wire, and we need a source of electricity, which is the battery. How an electromagnet works? A current of electricity flowing through a wire produces a magnetic field on the wire. You can see this field of magnetism. You cannot see this field, but it circles the wire. So the strength of the electromagnet can be increased by two ways. Number one, increasing the number of wraps in the coil, increasing the number of wraps around the nail. While second way is increasing the voltage of electricity in the coil. You can increase the voltage of electricity, meaning that you can increase the voltage of the battery. So we have two ways. Number one is increasing the number of wraps. Number two is increasing the voltage. So these are the two ways to increase the strength of an electromagnet. The difference between the electromagnet and the normal magnet is the electromagnet can be turned on or off, while the normal magnet, it can be turned on or off. It's always on. Uses of the electromagnets. We have many uses of the electromagnets, some of them in door locks, in cranes, in doorbells, used in computer desks, in loudspeakers, and also in phones. What are the dangers of the electric current? Dangers of the electric current. How to prevent being electrified. Number one, you have to cover all the electric outlets. Every one of you has outlets in your home. These should be covered in order to prevent any danger. So these all low placed outlets in the house should be covered with plastic covers. So here you don't have to insert any object in the wall plugs. This is safety rule number one. Moving to safety rule number two, we have when working with light fixtures, you have to wear rubber gloves, you have to wear slippers, and also you have to stand on a wooden ladder which is dry, not a wet one. These two rules. First one, you have to cover all the electric outlets and do not insert any objects in them. Number two, you have to wear a gloves and slippers, and you have to stand in a dry wooden ladder when you're working with light. Rule number three, electricity and water, they do not mix. So you have to keep away from electric appliances when you are wet. You don't have to use any electric appliances when you are wet. This is an important rule you have to follow. You don't have to use any electric appliance when you are wet. Number four, if your car gets caught in the power lines, in this case, live electricity could travel down the string of the kite and it can hurt you. So you have to pay attention to this. Number five, never climb a tree that's near the power lines because you may be in danger. Number six, or this is number six, never touch a naked electrical wire. Never touch a naked electrical wire because damaged electrical leads should be disconnected at the power point and fixed by an electrician. So this one, naked electrical wire should not be touched. Number seven, Stay away from electricity substations. The warnings are there for everyone's protection, so make sure you follow them. You don't have to get near any electricity substation. Number 8. Never stack PowerPoints. What the meaning of this? Stacking PowerPoints can cause fires. For example, here they are using the iron, they're using a refrigerator, and they're using a TV, all of them in one plug. So this is a big danger of being electrified or having maybe a fire in your house. Number 9, which is the last rule, know what to do in a case of electrical emergency. So you have to turn off the power at the power point and tell an adult to do this, not by yourself. Let's start with the exercises. Classify the following materials as conductors or insulators. Before we start solving this exercise, I have to know what the meaning of a conductor and what the meaning of an insulator. Conductor is a substance that allows electric current to pass through them, while insulator is a substance that do not allow the electric current to pass through them. Let's start with the first examples. Metallic spoon, spoon which is a metal, plastic cup, bronze medal, iron nail, wooden cube, and a paper. Let's start with the metallic spoon. It is metal, so it's a conductor. This is metallic spoon. Metallic spoon, you have to write it here. In the case of conductor or insulator, sure they are be written in the case of conductors. This is metallic spoon, it's a conductor. Moving to plastic cup. It's a plastic, so it's an insulator. Plastic cup. Bronze medal. It's bronze, so it's a metal, so it's bronze medal. It's a conductor. Iron nail. It's an iron, so sure it's a conductor. Iron nail. Wooden cube. It's from wood, so wooden cube is an insulator. Paper. Sure, the paper is not a conductor, so it's an insulator. Moving to question number 2. Consider an electric circuit that consists of the following components. We have 2 lamps, we have a switch, we have connection wires, and we have a dry cell, which is the other name of a battery. So don't be confused about this. Battery. Draw a diagram that shows the 2 lamps connected in series. Here we're going to use a closed switch. Okay, first you have to draw the battery, then we're going to draw the switch. 2 lamps, they are connected in series, should be beside each other. This is the symbol of the lamps, and finally you have to connect it here. These are the symbols. Let's say this is L1, lamp 1, and this is L2, this is lamp 2. Okay, this is the drawing. This is an important. Here we have battery. Already we did this. This is the battery. Connection wire. All of these are connection wires. We have 2 lamps. This is 2 lamps, L1 and L2. And here we have the switch. Draw a diagram that shows the 2 lamps connected in parallel. They are connected in parallel. So first you have to draw the battery. Should connected in parallel, so they are over each other. These are connected in parallel, and this is the figure. This is an easy one. How are the lamps in your house connected, in series or in parallel? Sure, they are connected in parallel, since when one lamp is off, the others will glow normally, so they are connected in parallel and not in series. Question number 3. Observe the diagram. Write D if the statement is true and write F if the statement is false. First, you have to look carefully to the figure. The figure is the key to solve this question. We have lamp 1, L1, lamp 2, L2, lamp 3, L3, and lamp 4, L4. So if I said, for example, what are the components of this circuit? How many lamps do we have? You have to say we have 4 lamps. For example, if I told you, what do we have here also other than lamps? We have a battery. What do we have also? We have connection wires. Let's start with the first one, number 1. The lamps L1 and L2. L1 and L2, they are connected in series. This is true? Sure not. This is false. They are connected in parallel. The lamps L3 and L4, they are connected in parallel. They are beside each other. They are connected in parallel. Sure not. They are connected in series. If L1 turns off, if this lamp L1 turns off, then L2 also turns off. L1 and L2, they are connected in parallel. So whenever L1 turns off, L2 won't turn off because we have more than one path. So if L1 turns off, L2 also turns off. This is false. Number 4. If L3 turns off, then L4 also turns off. L3 and L4, they are connected in series. So whenever one lamp turns off, the other will also turn off. So this is true. So you have to write D. 5. If we remove the dry cell, all the lamps will turn off. This is definitely true. Why? Because the battery is the source of electricity. It gives the electric current for all these lamps. Then whenever we remove the dry cell, we remove the battery, meaning that, so no voltage, no electric current. So all the lamps L1, L2, L3, and L4, all of them will turn off. Moving to question number 4. Question number 4 is talking about an electromagnet. This figure shows an electromagnet. Question number 1. What are the materials needed to construct an electromagnet? What do we need here? First, we need an iron nail. Second, we need copper wire. And we need a battery or it's dry cell. Step number 2, describe briefly the steps to construct an electromagnet. How can we construct an electromagnet? First, we have number 1, we wrap the wire, which is the copper wire, many times around the iron nail. We wrap the copper wire many times, like this case, many times around the iron nail. Step number 2, connect the terminals of the copper wire to the poles of the battery, positive and negative pole. This is how we can construct an electromagnet. And then number 3, we cannot test this one. Question number 3, give one way to make the electromagnet stronger. We know 2 ways. One way to make it stronger, we can increase the voltage. One of the 2 ways, increase the voltage. Here I told you have to mention one way. Already we studied at class that we have 2 ways. This number 1, or you can what? Second one, you can increase the number of wraps. Increase the number of wraps. You have 2 ways. I told you have to write only one way, so you write only one way. What is the advantage of using an electromagnet on using a permanent magnet? One advantage, we can control we can control the function of the electromagnet. Either it's on or off. We can control the function of the electromagnet. Okay? Moving to question number 5. Question number 5 says that match the two columns. We have lamp, dry cell, wire, closed switch. Which one is for the lamp? Sure, this one. Dry cell, this is for the dry cell. It's called a battery. Wire, this is the wire. Closed switch, this one is for the closed switch. This is an easy one. Easy question. Question number 6. Indicate which circuit is series and which one in parallel. Look at the figures A and B. Which figure is for the series and which one is for the parallel? Figure A is series, while figure B is a parallel one. In the series circuit, if we remove one lamp, what will happen to the other lamp in the series? What will happen to the other lamp? The other lamp will turn off. If I told you here, what is the type of this switch? You have to say this is an open switch. Okay, this is an open switch. Also, this is an open switch. Question number 7, which is the last question. Mention the safety rule that's being violated in each figure. Number 1, this figure, water and electricity don't mix, so you don't have to use electricity when you are wet. Do not use electric appliances when you are wet. This one here, they are using a lot of appliances in one plant, so they don't use many appliances in one plug. Or simply you can say stacking points, never stack points. Last one, this figure, this one is for this figure. This figure here, inserting his finger inside the outlet. So cover all the outlets in your home. Outlets, and do not insert any objects. And don't insert any objects in it. So this one is for the safety rules. Maybe in the exam I'm going to give you one of these. Maybe I'm going to tell you, talk about some of the safety rules, choose 4 safety rules and talk about them. You have to know these safety rules. You have approximately 9 safety rules, so pay attention, guys. This is an easy one. Study well and good luck for your exam.